Recently I've been learning about caching, and I was so curious. From so long time I want to learn this and why we use cache in the system designs perspective, and also in our development, and what it actually benefits us. So I am a guy who love by doing, learn by doing, guys. So I in this video I just created a small tool, CLI tool, to uh, perform perform test between database and the cache, why these two differs, and why these two needs in our system design kind of perspective to understand its speed and accessing of the data. So hey everyone, this is Jaramal Pushparaj. I am have been learning this tech for around 5 years, and developing things and curiously understanding the things which is running our every each and every day use apps. So welcome, and if you want to join with me in this journey of learning things, and I would love to join with me, guys, please to subscribe and like this video, and let's see what is caching in. First I will going to introduce you about small little theory to understand and know the terms which I'm going to use in this video, and we will move on to the tool of simple tool which is written from the goal line. So let's get started. Stuff I will become small. Now I'm smaller. Okay, so the cache and caching, these two terms you need to understand. The cache is a high speed temporary storage area for frequent use data. The caching, the process of storing copies of these files in the cache to speed up future request. So these are the two things, and we need to understand two parts and why it is we using. So database and cache. Database simply stores every data in the SSD or hard drive. Cache is stored every data in the memory. So memory is always fast. So this is a purpose for that. This logo, don't care about it. It is a Redis logo. So it is one of the crash tooling. Okay, in system design we have so many types of cache. Cache aside, write begin caching, write through caching, cache prefetching, query caching, etc. If you want to learn about this, go to this resource and read about it. It was such a nice write up. And yeah, so but most popular and well used and currently being used in a lot of system is this cache aside, because it first checks the cache. If any request comes in, if any request wait a sec yeah if any request comes into the server, it first hit the database. So sorry, first hit the cache hits read data from the cache. If is miss any cache, that means we will say if there is no data what we need, we call it as cache miss. In that case, it go and fetch the data from the database, read data from the database, then update the cache, also respond to the request which is received, has it's received. So then yeah, this is about the cache, how many methods we have. So we have other few methods, and you can go and learn it here, because I wanted you guys to learn by yourself. I can show you the path, you can go it in the way and explore cache. And it was nice. I don't want you guys to make you sleep by saying uh, a lot of things, right? In this case, memory is not infinite like we see here. It is so finite. So we need some policies or any algorithms to evict the data which is stored in the cache. So the three of popular algorithms are here. LRU, which is least recently used. It is like whichever the cache data is recently been accessed is evicted out. And then the least frequently used, it is uh, the thing is how frequent the cache is used. So according to that, if it's leastly used, it will get evicted by from the cache. Then this FIFO method, it's usually in the queue data structure, like first in first out. So whichever the data comes first, it will evicted out at first. So this is it, and I want you to want this to compare this experiment, so I want to move to that experiment right now. Yeah, so I just write a small program which parallelly go and fetch the s- data from the cache as well as the database at the same time. So I want you to guys to first understand my tool which I written here, which is not a tool, it's just a one file go program. So I just going to run this command with the db parameter, so it will give me the benchmarks of that db alone. So you can see here the database responds with 2.2349665 millisecond. It is millisecond. So you can now I'm going to run and compare this, and our code will respond with how many times it is faster. So let's run this normally. You can see the mu s represents the microsecond. So 266 around 7.84 times faster than the database. So from this what we can understand is it is faster. We used fast accessing the data. So the main point why we need this much of time constraint and why we need this much of time constraint to watch it carefully, just a microsecond, right? For this particular case it's just a 1 second, one request, so we don't need to care of in the local system. But when we move to the uh, part where we handling thousands and millions of users, you can start to notice the difference. So here I answered it previously because I need to do some small approx calculation to say these things, you know. This is, I got a call, yeah. So why we need cache? Take example where you have application below. Example is for number of user concurrently make one request alone. It is the example which I took was one request per you know per second. So I just hit the time database. So now I'm going to compare this database. So for one request for one user, it would take 1.48 millisecond when there is a lot of data. Now I have now we received 2.08 something millisecond, but previously when I'm running this program I got 1.48 millisecond, because that time it is way more faster. Now it is slower. Now I'm currently testing it. So for 100 user it would approximately take 2 to 5 millisecond for 100 user concurrently uh, hitting that data which they need concurrently. I'm talking about parallelly and concurrently make one request alone. I'm 100 users making concurrently one request. It would take 2 millisecond. Okay, now then 500 user it becomes 10 to 20 millisecond, and when it grows to 1000 it takes 22 millisecond. You can ask Jeromel that 20 to 50 millisecond is necessary. Yeah, it is only taking for the server to get the data from the database. So then that server needs to do some process with that data, then it needs to respond, and there are some latency in the networks too. So the networks also have some problem on latency. But now we only solely focusing on the backend and make it faster, right? When it becomes 10 k user concurrently hitting that one request, 200 to 500 approximately, only this is the approximate range, millisecond would take. So consider this, you will not have one request to the database at concurrently, because the you have thousands of endpoints in one application, and sometimes that thousands of requests, that thousands of API endpoints needs this much of thousands of information they need to query from the database. So consider this, it would take around so much of time, and it even cross seconds. So for this we need a caching. So when, as we saw earlier, it just first hit the cache, and did you notice these examples from your shopping experience when you open long time after the Amazon for loading open the first time? It takes time, some small amount of 1 to 2 seconds of time. After that, when you hit that same page again, it will reduce the time and respond with a 0. Some millisecond. So it was amazing architecture and the system design behind the Amazon and Google and etc., because they are handling trillions of users and trillions of requests at a time. So it was a great deal. So the time is a great deal. So we need cash. So that's the sole purpose of cash. When I was work, when I was trying to learn and grasp and understanding, comes to understanding of this caching. So it really, helps me to understand. So I just up the Docker containers to use Redis and also the MySQL. So you can see the logs here. This is my Redis, and I use SQL database MySQL for the comparison. But you can say we came a lot of things, but the caching is a key part in every systems which we are currently have handling millions of and trillions of users. So this is what I understand, and we have a pretty much more and deep things on this caching area also. But overall, to grasp an understanding and foreseeing the things why we need this amount of time constraint to watch, is mainly because of we need to reduce the latency to our user and give our respond very fast. So the in that part, caching helps in a great way. And when you do caching in a network level, it is called CDN, content delivery network. I think I'm saying right, but it's also the one of the nicest thing, because it is comes in a different chapter and whole new video, because it was nice one, because it is you know have the topic in terms of loss of distributed computer and shrouding, and you know we need to see a lot of redundancy over it. It was amazing when we learn things by doing, and I would suggest you guys, and this is my way of learning things. If you learn one concept, go and do build one code and set of program and see it yourself by your naked eye. So then you will get an whole new understanding than just listening to the tutorials and stuff. So thank you for watching, and if you want to continue with me in this learning process, and previously I did a video on data is everything in the computer science. Without data there is no computer science, so we don't need computer. So because of the data, only every field comes around, keep the data as a center. So that if you want to check it out that video, please check it out that and do follow. So see you guys in the next, in a beautiful interesting learning concepts in the computer science and the software engineering. So see you.